Hey guys, it's October 19th, that is Monday, and this is Miss Figueroa. Today we're going to be doing the review for test 2.2. There is a typo on the PDF. It might be fixed on your version, but this one did say 2.1, but it is the test 2.2. It's the second test of the second 6 weeks, and it is tomorrow. So this test is all about quadratic. So it's about quadratic functions and their graphs and their attributes. So I'm going to do one of each. I'm going to do one that is in vertex form and one that is in standard form. So I'm going to do number one here. We have to find the transformations, the vertex, the minimum and the maximum, either one, the axis of symmetry, the domain and the range, and then sketch a graph. So on number one, first it says to list our transformations. So remember when we're in vertex form, it's super easy to find our transformations. So we look at the parts that are different. We've got this, and this. So I was going to say standard form. Vertex form of a quadratic function is y equals a x minus h squared plus k. So the transformations on number one, the first thing that I see that's different is that negative sign. So we have a reflection across the x-axis, meaning it's not going to be facing up, no, it's going to be facing down. Then we have that 2 for the a value. 2 for an a value is a whole number, which would be a vertical stretch. Then we have that plus 1 on the inside with the x. Remember, with the h, we're taking the opposite. So since it is plus 1, we're moving to the left. So that is a horizontal shift. Left 2. And then we have minus 1 on the end. Remember, what those last numbers, we take them as they are. So minus 1 is going to be moving down. So we have a vertical shift. Down 1 unit. So those are my transformations on the graph from the parent function. And then it says to find the vertex. When we're in vertex form, the vertex is hk. So remember, we got to take the opposite of what we see with this h. So since we see plus 1, that means it would be x minus negative 1. So remember, we're taking the opposite. So instead of saying that my vertex is a positive 1, it's going to be a negative 1. That's the only tricky part really with the vertex. Make sure you're taking the opposite of what's with x. So we have negative 1, and then for k, we take it as it is, so negative 1. So the vertex of my graph will be at negative 1, negative 1. It will have a maximum or a minimum, and since we said it would be facing down, it'll have a highest point, so it's going to have a maximum. So that vertex will be a maximum. The axis of symmetry goes straight through that vertex. So the axis of symmetry is the x value of my vertex. So axis of symmetry is x equals negative 1. It's that vertical line. And then domain and range. As I said before, domain of a quadratic will not change because we're not going to, oops, I was going to write quadratic. We're not going to change so much that we won't touch every single x value. We're going to touch every single x if we keep zooming out of that function. So if you could pinch this graph right here and zoom out and zoom out and zoom out, you're going to see that it will extend all the way left and all the way right forever and ever and ever. So the domain is going to be negative infinity to positive infinity. And then the range is what changes, and that depends on the vertex. So since we said that the vertex was a maximum, that is the highest point that we can have on our graph. So the highest y value we can have is -1. So that means we're going to start somewhere at negative infinity and go all the way to -1. So now we've listed all the attributes of the function, but we still need to graph it. It says to sketch a graph. So we have the vertex on there. We have our axis of symmetry. So we just need to find any, let's say, 2 points that we can reflect to the other side. So let's see where the graph would be for x equals 0. So this is still number 1. I just don't have space. So if x was 0, we're going to plug in a 0 for x. We have -2. 0 plus 1 squared minus 1. So y equals -2 times 1 plus 0 is 1. 1 squared is 1. And then minus 1. So -2 times 1 is -2. -2 minus 1 is -3. So at x equals 0, our point is 0, -3, because that's my y value, -3. So we would go to the graph and go to 0, -3. And then let's find another point. Let's plug in a 1. So let's say if x is 1, let's find what our y value would be. So we have -2, 1 plus 1 squared minus 1. So that means we've got -2 times 2 squared minus 1. -2 times 4 minus 1. And -2 times 4 is a -8 minus 1, which is -9. So we would have the point 1, -9. We go over to 1, go down to -9. And then since we drew in our axis of symmetry, we can just reflect onto the other side of that line. So here I would have on the left side that point, and then that point. So my quadratic function would look something like that. So we've got our transformations, vertex. We know that we're going to have a maximum. The axis of symmetry we found the domain and the range, and then we found 2 extra points so that way we can reflect across that axis of symmetry. So like I said, I'm going to do one of each type. So this was our vertex form, so I'm going to move on to the next page so we can do one that is in standard form. Alright, so on the right side, we're working in standard form. Standard form, we've got y equals ax squared plus bx plus c. When we're working in standard form, it is a little more difficult for us to find the vertex and find the axis of symmetry because we're going to have to do a little bit of math here. It's not hard math, but like we said before, when we're given vertex form, that's all in the equation for us. When we're given standard form, we kind of got to take it apart and find it. So in standard form, let's do the axis of symmetry is x equals, remember it's a vertical line, -b over 2a. So we just got to plug in our a and our b so that way we can find what the axis of symmetry is. And then in order to find the vertex, we have to plug in that x value and find what the y would be. So on number 5, we've got axis of symmetry. Let's see. Our a value is -2. Our b value is negative 8. And our c value is negative 12. So x equals negative b over 2a. So I have negative of negative 8, which cancels out the negatives. So 8 over. And then 2 times negative 2 gives me negative 4. So 8 divided by negative 4 is negative 2. So that means my axis of symmetry occurs at x equals negative 2. So here is my axis of symmetry. So that's going to be the line that cuts the vertex, not the vertex, that cuts the quadratic straight in half, and then the vertex will be somewhere on that line. So since I know that the vertex is on that line and I have an x value, then I can just plug that in to be able to find the y value. So for my vertex, I know x equals negative 2, so I'm going to plug that in. Y would equal negative 2 times negative 2 squared minus 8 times negative 2 minus 12. So negative 2 times positive 4, negative 8 times negative 2, we get positive 16 minus 12. Negative 8 plus 16 minus 12. Positive 8 minus 12. Negative 4. So for our vertex, our y value is negative 4. So the vertex is the point negative 2, negative 4. This is our vertex. So since we have a negative in the front, that means we are going to be facing downward. If we're facing downward, we have a maximum. So my vertex is a maximum. And then for my domain and my range, my domain will not change. And then my range depends on the vertex, and the vertex goes all the way up to negative 4. And it's starting at the bottom since we're facing down all the way up to negative 4. So we still need to find all of our transformations, and we still need to find all of our not all of our points, 2 more points, so that way we can graph the rest of it. So let's see if I can move this so I can cover the graph. Okay. So I need to find more points. So I'm going to plug in x equals 0. Let's see what happens there. So y would equal negative 2 times 0 squared minus 8 times 0 minus 12. Y would equal, that cancels, and that cancels because we're multiplying by a 0, negative 12. So at x equals 0, we're at 0, negative 12. 0, negative 12. I know that I'm going to reflect across this line, so my other point can be over there. And let's see what happens when x is negative 1, just so we can get a point in between those two. So y would equal negative 2 times negative 1 squared minus 8 times negative 1 minus 12. We've got negative 2 times 1 plus 8 minus 12. Negative 2 plus 8 minus 12. 6 minus 12 negative 6. So we would be at the point negative 1, negative 6. Negative 1, negative 6, and then reflect it. So we can connect those points. And then I still need to list off the transformations that happen from the parent function to this function. So let's cover this graph. Transformations. So I see that it is facing down, and that's from that negative in the front. So one of my transformation is a reflection across the x-axis. I also know that my vertex changed because in the parent function it's 0, 0. So it's a horizontal shift left 2 units and a vertical shift down 4 units. And that's how we end up with that vertex of negative 2, negative 4. And then as far as a vertical stretch, vertical shrink goes, we're not really sure just given this information. Given this negative 2x squared minus 8x minus 12, we're not really sure if there's going to be a stretch or a shrink, and we're not given the graphs side by side. So think about the parent function. If I reflected the parent function and moved it over left 2 and down 4, would the other points be where they are? And I know that's a little confusing. So let me see if I can make it make a little more sense. The best way that I can make it make sense is for you to graph the parent function and the function that you're given, and you can physically see whether or not it is wider or it is shrunk. So the one that we're dealing with has been vertically shrunken. And here's the thing. Standard form is ax squared, right? Vertex form is ax minus h squared plus k. Do you notice that these a's are the same? So since we have an a of 2, then that means we are going to be shrinking. It is a whole number. So we can rely on our equation after all. If you do need help by graphing, that is the easiest way to see it. But with our a values, they're always going to tell us, are we shrinking or are we expanding? So we got our 4 different transformations for number 5. And I know there is a lot of work that goes with this, and I'm sorry that it doesn't all fit right there. But we've found all the information that it's asked for. We found the vertex, we know it's a minimum, we found the axis of symmetry, we found the domain, the range, and all of our transformations, and we were able to sketch it. So without a calculator, except to check our work, we were able to graph these 2 different functions in 2 different forms. So on the test, you should be able to find any of the attributes just given the equations, just like we just did. So for your review, you do have to do the other 6 problems. If you have any questions, you can always reach out to your teachers, and we are more than happy to help you.